So here we go, we're recording, here we go. So we're going to do trig starting today. How much trig have you guys done?
Very, very little.
And is that very little SOHCAHTOA basically?
Yes.
And we also
Okay.
didn't have a real
Barely
teacher
so
for that.
That was before the,
That
okay.
was like in the transition. And it
Okay.
was,
Yeah.
All right, so the good news is we will do SOHCAHTOA also, okay? But we're going to actually start a little bit before SOHCAHTOA. And these first two sections are probably the most important part, okay? This first section, so it's going to be like kind of confusing at first, and then all of a sudden you'll be like, okay. And this is very different than anything we've done so far. So we still need basic algebra skills, but basically this is just memorization. Okay, and I really am going to strongly suggest that you memorize the things that I'm telling you to memorize. Not because you can't just look it up, but because in a future class that you take, the quicker you are at recalling these facts, the easier that class gets. Okay, and I kind of told the first pre-calc class, you know, this knowing trigonometry really well is the difference, like if you're thinking of the AP test, of you getting a 3 or you getting a 4. I mean, it shows up all the time, and it's not difficult, but if you don't have it memorized and you got to sit there and think through, because you'll be able to think through it. You don't have to have it memorized, right? But the time it takes for you to think through to get the right thing is wasted time, okay? So it is significant, but it is all memorization. So trigonometry is basically the study of triangles, and then calculus came around and they're like, oh my God, look how much more we can do with trigonometry. So we're going to do pretty much all of that, and like I said a second ago, SOHCAHTOA is part of it. So the thing up here is for Ashlyn. You can say hi to Ashlyn if she's listening, or not if you don't, whatever. Yeah, there you go. Well done. That was super exciting. I'm sure she is glad that she's doing pre-calc while in Africa or wherever she is. Okay, so everything that's on the screen is the same thing over on the board. So I'm going to try to make this work over here. This is the first thing we got to know, right? This is angle in standard position. So what I'm talking about here is we got to think of a coordinate plane, and your initial side is always on the x-axis, okay? And I have some things that I'm not super concerned about, but it may show up sometime. This alpha and this beta stuff, I probably will never ever refer to anything as alpha and beta. But the thing that you want to keep in mind is to kind of follow the arrows. If we are talking about a positive measure, then that means we're going counterclockwise, okay? So in this direction, okay? And that's what the alpha is. If we are talking about a negative, we're going in the clockwise position, or I'm sorry, rotation. Okay, so is that okay? All right, and I'm going to say that 100 times, so if it's not, you need to speak up. Because again, this section and the following section are the real important ones. Theta is going to be your buddy. Pretty much anytime you see theta, that's going to refer to the angle measurement itself. We are going to start with degrees because I doubt that you guys know radians very much at all. Okay, you actually know them a little bit better than you think, but barely at all, and we'll get to that here in a second. So we're going to start with that, and then we're going to move to radians, and then at one point we will only deal with radians from here on out, okay? So this paragraph down here says, since the terminal side would be the same when going either clockwise or counterclockwise, I guess it should say if, I missaid that, we can have something called coterminal angles, okay? And that just means that the terminal side is in the same place, but it can be measured in multiple ways. How's that? Is that okay? I don't know what that turned out. Okay, there we go. Try this again. All right, so what would you guys say theta is here? So this is the first part we got to talk about. Like, just give me like some kind of angle. What do you think? 135. Fine. Can we make it 140 just because that's a rounder number? Yeah. All right, let's say this is 140. Is that okay with everyone? What would it be if we went in the opposite direction? Well, close to 220. Because 220, okay, so 220 means we're going in this direction. So how about negative 220? All right, so if this angle here, if theta is 140, is it okay to say that 140 and negative 220 are coterminal? Is that okay?
Yeah.
So the terminal side is the same, because remember, the initial side is always here. Okay, so is it okay to say 140 is the same as negative 220?
So you measure from the initial side.
You always are measuring from the initial side. Right, counterclockwise is positive, clockwise is negative. Fair enough? So I'm looking at 368. But real quick, what is, if the initial side is always here, what is the degrees right here, where the lightsaber is? What is it? 90. What is it if it's all over here? 180. And then right here? 270, and then all the way around is 360. Is that okay with everyone? Okay, so we're going to do 21 through 24 together, and it's kind of like what we just said, but I just want everyone in the right frame of mind. What are we going to say, and this is just an estimate, what are we going to say 21 is? What'd you say? 220, bless you. What does it have to be bigger than? 180. Okay, so can everyone say everyone's happy with 200 or 220? And then what quadrant is that in? Okay, third. This is going to be super important. Know where you are, okay? Know what quadrant you're in. That's going to be important in the next section. All right, so then 22, what would we say 22 is? 110, fine. Is that okay with everyone? Can we call it 110 as an estimate? Right, it has to be bigger than 90, but less than 180 for it to be legitimate. And so that puts us in which quadrant? 2, okay, is that okay with everyone?
So is the quadrants like where the arrow ends?
Yeah, so it's basically where your terminal side is. Yeah, that's what I'm talking about. Where is the terminal side? And the quadrants are the same as what they've always been. Okay, so 23, follow the arrow. Negative 45 or something like that. Is that okay? Right, because we're going in the clockwise rotation, because that's what the arrow says. You're shaking your head no. Well, would you, if you would say that, I mean, does that look like a 45-degree angle?
Yes.
Okay, so do you see how it's dropping from the initial side down and we're going clockwise?
Yeah.
So it has to be negative because we're going in the clockwise direction. And so then we're going to call it negative 45.
So you're just guessing a number, like that makes sense, like it doesn't?
Yeah, right, yeah, we're just estimating, yep. So that would be the fourth quadrant. What about number 24?
Yeah, the quadrants though. So 1, 2, 3, 4.
1, 2, 3, 4.
So negative 3 to 5.
Okay, yeah, negative has to be bigger than what? Negative what? Has to be bigger than negative 270? Is that okay with everyone?
The arrow thing is not making sense to me.
The which?
The arrow thing.
Well, okay, so
Like what's that telling you?
this is telling me that you guys are digital clock babies, right? Like clockwise and counterclockwise.
I understand that, but I
Yeah.
don't understand how it corresponds to the graph that we just made, like that graph.
So, right, anything that's moving counterclockwise off the initial side. So it's like it starts off as just a line going from the origin off to the right. And then you take that line and you start spinning it in either clockwise rotation or counterclockwise rotation.
But does where the arrow ends up on the angle, like does that correspond to like the number itself? Like not whether it's negative or positive, but like the actual number value?
So I think what you're asking is it okay to say that a positive 90 degrees is the same as a negative 270 degrees? You don't like that?
No, that wasn't like what I was asking.
Oh.
Like does where,
The red is the triangle.
yeah, I know that, but like, Never mind.
It's just the direction of your pencil. So if that line was straight, like the 180.
So like where it falls on the angle, or like the
Oh,
axis doesn't correspond to the actual number itself, like whether it's like 270 or 275.
Yes.
That's what I was asking.
That's the number.
Yeah. Coming out that way.
The arrow, that's this
Right.
arrow, not against the
we're doing 30.
All right, so let's finish, let's do part B on 30. So negative 120, right? We're starting over here on the initial side here. So again, let's count it off, right? Negative 90, okay? And then if we keep going, we're going to get to negative 180. So we got to stop, right? Like maybe here. And maybe not exactly right, but right. This right here, this green. The green would be negative 120. Is that okay?
Oh, it's negative.
All right, let's do 32. Let's do 32. Right, here's our initial side. It's always right there. Right, are we going for 32A? Are we going clockwise or counterclockwise? Counterclockwise, all right. We're going to count them off. Here we go. We're at 90, 180, 270, 360. Uh-oh, now I got to keep counting. 360 and 90, I believe that's 450. And yeah, you better calculate that. 450 and another 90 is 540, is that right? Plus another 90. 630 plus another 90. 720, up a little bit more. There's our 750.
Oh, boy.
Is that okay?
I think it's all right.
Would that also just be 30? 30?
Was it 720? Yeah, so that's also 30, correct. Yeah. Is that okay?
So when you draw that, you have to draw the circles every time you draw that?
No, absolutely not. No, this is just for illustration, yeah. So no, so how would you know that it's 30? What are you trying to do?
How many 360s?
A factor of 360.
How many 360s can we go through? And then it doesn't really matter. You don't even care, right? Because you just want that measurement of that terminal side.
Why can't you have an angle that's 750 degrees?
Have you ever seen Dominique Wilkins dunk the ball?
No.
You need a lot of degrees to watch a man like that dunk a ball.
When you spin around one,
Yeah, so just more spinning.
I know it.
Oh, sorry, Emily.
They were trying to teach me basketball like Monday at school, and I was so confused.
So, Emily, we got a lot to talk about. So the answer is well, I don't know, if you're looking at like a piston firing off or something, right? This thing's spinning super, super, super fast. So it has multiple 720 degree spins. But it doesn't really matter how many times it's going around and around and around. It's just where does it end up? Okay?
How many times it goes around?
Yeah,
Represented with an angle.
so it'd only be a 30-degree angle.
yeah, so this is basically just a 30-degree angle. Yeah.
So why don't we call it a 750 degree angle?
Because it spun around a few times before it stopped.
So
But do we then need to say that it's a 30-degree angle?
Yeah.
Well, this is just sketch it in standard position, so that's all that he did.
But if we did something later, would we?
Yeah, so you would basically ignore the first 720 degrees and just deal with the 30. But you have to know that it's a 30. Okay? And then, all right, so then do we have to do B, or does that make sense? We're just going in the other direction? Is that okay with everyone? Okay. All right, so then let's go to, all right, it says, determine two coterminal angles, one positive and one negative for the given angle. So I don't feel like doing your homework right now, so let's do 34 instead. So we have this theta, and theta equals 120. Okay, and so we need to come up with coterminal, one being positive and one being negative. So if you really understood what we just looked at, you can do the first one pretty easy. So
360 minus
480 and then negative.
oh my gosh. I totally did not spell that correctly. Sorry about that, Abby.
Yeah, so if that's 120, then it'd be 360 minus 120 is 240. We're gonna make it negative.
So 120 is one of your angles.
So 120, no, this is just, we're gonna make two more for 120.
480.
Okay, so how'd you get that one?
I added 360.
Yeah, so right, so if we're at 120 and we add 360, aren't we just getting back to 120 again? But really, that would be 480 as one of our coterminals. That's our positive one.
And then negative 240.
Okay, and so then the second one is just 120 minus 360, right? Is that okay with everyone? Not random, full circle. Right?
Wait, so what's coterminal again?
Coterminal just means that two angles that have the same terminal side.
So they share the one side. They share both sides.
Oh, okay. So you always add and subtract 360 to your coterminal?
If you want another coterminal angle, all you have to do is add or subtract 360. Yes, correct. Is that okay?
So why is it not 480? Like, wait.
No, both those answers are true.
Okay.
All 120, 480. Oh, you guys let me write down 120 again. Isn't it 220?
Yeah.
Yes, in fact, it's not even, it's a negative 220. Sorry. Yeah, there we go. Right, so 120 is the same as 480 is the same as negative 220. Is that okay? Yeah, I don't know what's happening right now.
So if it was going counterclockwise, it would be 480,
I'm
and
s-
clockwise would be negative 240.
Say it again.
So if it was going counterclockwise, it would be 480, but
Correct.
counterclockwise would be negative 240.
You just said counterclockwise twice, didn't you?
Or
So-
clockwise would be negative 240.
Clockwise would be negative 240, yeah. I'm still getting over the fact that we don't know what dunking is. That's why I can't subtract right
I
now.
do know what dunking is. I was just
All right.
confused on Brady's shot on Friday. I didn't know how many points that was.
Was it a dunk? Was it a dunk?
No, it was a half-court shot.
Okay.
Deep three.
I was gonna say,
I thought we were going to go overtime.
I was about to agree with you that a dunk should totally be worth more than 2 points, but
So should a half-court shot. Like, he like.
what the half court shot is more?
I thought
How much is
like,
it?
it's only 3, but I mean, like, it should be more than
3.
3? Oh, yeah. I mean, like, 4. How
Yeah,
about
but
that?
like.
You think it should be worth 4 points?
Yeah, I mean,
Why
how
not?
many people can do it?
And then everyone's just gonna be chucking up 3 or half point or half court shots.
Where the?
All right, Eric, let's do part B. Eric, let's do part B. Let's do part B. We need to get a little further. This is part B, right? Same question though. Coterminal to this. Well, so negative 390 would be like that, right? Follow the circle around or the arrow around. And so then what is a negative coterminal angle? Okay, so we could do negative 390 plus 360, right? Because we're just spinning in a full circle. It's called a 360 dunk there, Emily. Negative 30 degrees would work. Okay, but that would be another negative, so let's get another positive.
So add, you could do
So
multiply.
add 360 twice.
Yeah, so then we could just add 360 again. So then we could be at positive 330 also.
Wait, why did you do the negative?
Because the directions are asking for a positive and a negative coterminal angle.
Use the one answer.
So the point is that you can just add 360 as many times as you want and you still have the same angle. Okay, or you can subtract 360 as many times as you want and you still have the same angle. That's kind of the idea.
Almost like the overlap is what you're measuring.
Can you break
You're-
that down, like what you just said about if you're subtracting, you have the same angle?
Say it again.
I don't know what you said. You said something about like if you're subtracting, you have the same angle.
So what I just said was that if you subtract 360 degrees 15 times, you're going to have the same coterminal angle like 15 times. You're always just going to keep ending up on that same terminal angle side or terminal side. Or vice versa, if you add 360, right, you could just add 360 as often as you want. But no one really cares what those are. They want, everything is gonna be between 0 and 360 all the time for you. Okay, but you may have something spinning, stop it. Where does it end up? Okay?
So you get the same coterminal angle for every time you add or subtract 360?
I'm saying that wrong. It's the same terminal side.
Okay.
So any angle with the same terminal side is called coterminal. Okay, so and then the next part down here is supplementary and complementary. So I trust that you guys remember what those are.
180 and 90.
Complementary, two angles that add up to be, complementary is 90. Supplementary, they add up to be 180. Okay, so I'm not gonna go over that part. Yeah, you guys are gonna have to deal with that. So now we gotta talk about radians real quick. We got till 46 or something?
Yes.
Okay, so the next thing is basic radian values. And you guys have seen 2 pi before. Where have you seen 2 pi before?
2 pi r squared.
2 pi r squared, okay, that's the circumference of a circle. Okay, and so what they're saying is, we're just gonna, so you can either look up on the screen or over on the board, right? I know it's uncomfortable that Ben is like staring at you, but like, right? Like, he wanted to do it. He wanted to be part of the class.
Can I get a picture?
Huh?
Can I get a
It's gonna be on YouTube. You can take a picture. Yeah, you can take a picture. Ben knows he insisted that he be part of our class. So if you guys look at the red parts that I put up there, I don't have, because we're running out of time here. Is it okay? Can you be okay with saying 2 pi is the same as 360 degrees?
Yeah.
Like, it just is.
2 pi.
So, yeah, and maybe I'm doing this in the wrong order. So how about we back up for a second and look down below, closer to Ben's head there, because we're switching to radians now. So if I said that 1 degree is the same as spinning 1/360th of a circle, would that make sense? Right, because we'd need 360 of these to get a full 360 degrees. Okay, so 1 radian is slightly different, and I'm going to try to say this so that it makes sense. So S in this picture is the arc length. Is that okay? When you are spinning from your initial side, when it so happens that your arc length is equal to your radius, you have traveled 1 radian, or you've spun 1 radian. Is that okay? So if that's okay, flip to, and then, so flip to page 361, and I'm looking at the very, very bottom, figure 4.6. And so if we say that, and again, circumference is 2 pi r, because we're talking about a full spin. We're just dragging, it's like you put a pencil at the end of the radius and drug it around 360 degrees, and that's 2 pi. That made a full circle for us. Okay, that's where the 2 pi comes from in that equation. So is it okay to say, like if you're looking at figure 4.6, let's see, how can I say this? So 2 pi is like 2 times 3.14, right? So that would be 6.28. So would it be okay to say that there are more than 6 radians in a full circle? If you can accept the fact that we just did that as our definition. So if you're looking at figure 4.6, right, they show you where those radians are. And now I want you to look at it and say, yeah, okay, great, or ask a question about it. But eventually you're just going to not even care about that very much. Okay, it's kind of a definition, and then we get away from it quite quickly for the most part. Is that good enough? I don't even know if I've said anything. So having said all that, okay, so let's do this.
If it's a 60-degree angle, there's 3 radians, and like.
Well, okay, so here let's do it this way real quick. Look at on page 367, number 1. We're going to estimate the angle to the nearest 1/2 radian. And so if you're looking at number 1 and then flip back to 361, how many radians would you say number 1 is? You're just kind of coming close. Well, 2 or 2.5. Is that okay with everybody? Does that match up fairly closely to the picture 4.6 on page 361? Is that okay? And so then what would 2 be? And don't look at this stuff on the board or Ben. 5. Is that 5? Is that all right? 5 radians? And then so 3 would be,
So how do we change that, it's to the nearest 1/2? Like,
you're just trying to accept the fact that we're switching from degrees to radians right now. And that, in
what does
the,
it mean when it says the nearest 1/2?
well, they're just trying to get you to guess, to think of like what a radian looks like.
So these
So
what
we
is-
just use whole numbers or half numbers, just trying to get close. Like we said, 2.5 or 5.
And so 3, we should be saying negative something though. What should we be saying? Negative what? Or maybe, yeah, negative 2.5 or something. Is that all right? As long as you're fairly close, I'm okay.
Oh, yeah.
What about 4? Negative 3.5 or maybe negative 4 or somewhere in that. Is that okay with everyone? All right, so I know we're running out of time, so real quick. The other class, we got a little bit further. I want you should be able to do